Okay, this is a video for Algebra 2. This is Unit 1, Section 4, and this is relations and functions. Okay, and here are our objectives. We want to represent a relation in multiple ways, including equations, graphs, words, and tables of values. Okay, number 2, we want to determine if a relation is a function. We want to determine if a function is one-to-one. And we want to determine if the domain and range, determine the domain and range of a relation, and then evaluate function rules. So let's talk about a function. What is a function? So on your notes, I want you to write this. A function. Now the first thing I want to talk about with a function is the root word. The root word is fun. Okay? Yeah, I know. Okay. Okay, so a function is like a computer. Okay? So like a computer. All right. What happens in a computer if I hit the button X? Well, let's just say, what happens on your phone when you hit the home button? What happens? It takes you to a spot, and it gives you, and it either it unlocks the phone or it prompts you to unlock the phone. What happens when you plug in the right combination to unlock your phone? What happens? It unlocks the phone, right? Let's say that you click on the email app button. What's going to happen? Does it? If I hit the email button on the phone, it opens the email. How many times do you hit a button and the computer or the phone does like 10 different things? Does that ever happen?
Only if it gets water damage.
Well, yeah.
Or sometimes, like my phone, I've only ever.
But I'm just asking on a typical thing. If you're typing on your phone and you hit the K button, what pops up on the screen? A K, right? Only one thing usually happens, right? Okay? That's what a function is. Your computers and everything that you do on a computer, everything you do on a phone or a remote, you are operating within a function, okay? So it's like a computer, okay? Your X value, also called your input, is like pressing a button, okay? It's like pressing a button.
Do you relate it to like how there's like two different functions on the same key? When you press shift, it uses the other.
Right.
I don't know.
Yeah, no, and that just says like, and the program says, okay, if you press shift, then as a result of you pressing shift, pressing a button, then this whole new set of buttons goes, and then if you hit both at the same time, then the function happens. Like, you get a capital letter. Yeah. It's just a function. That's another X value. So the idea, here's the thing. When you like press a button, that's like hitting an X value. That's an X value. Okay? The Y value, also called the output, is the result from pressing a button. Okay? And here's the thing. The definition of a function is that for every X value, so for every X value, there is only one Y value. So for every X value, there is only one Y value. Okay? The whole concept of technology and computers is based off of this idea, okay? That, I push a button, that's an X value. The result that we get on the computer screen is the Y value, okay? That's the application of it. That's so you guys can make sense of all this stuff, because it's kind of weird and tricky if you don't put it in terms of computers. And that's the thing, guys, is since you guys are of a technology age, technology generation, you are so used to this idea that you don't understand the mathematics behind it. Okay? So, let's talk. So, we have all these different things here, okay? We have a function, okay? We can represent that as an equation, okay? I can tell if that's a function by looking at the equation. I can tell if I have a function by looking at the graph, okay? I can tell if something is a function by looking at the tables of values, okay? Or I'm sorry, the ordered pairs as points. I can tell if I have a function by reading what the words say about that function. I can tell if I have a function by looking at a table of values. All 5 of these things represent the same thing. They represent this equation, the graph, the ordered pairs, the table, and how you'd say it in words. Okay? Now, another thing we need to look at is, what is the domain? Anybody know what domain stands for? What it means? Huh? No.
It's the origin, basically.
Not really.
I'm trying to remember.
You used to know. Yeah, it's one of those things that you knew at one point, but you don't know anymore. Domain is the same thing as x values. Okay? And another word for x values is the word input. Okay? And when I am asked the question, what is the domain? I ask myself, ask yourself, where do I have x values? Have x values. Okay? So if the domain means x values, which are your inputs, I ask myself, where do I have x values? And I answer that question, and we'll go over that. Okay? What do you think the range is? No. If domain is x values, the range would be the y values. Yeah. So the range, these are your y values. Okay, also known as your outputs. Okay? And I ask myself,
Can I reply?
dude, we're recording in here. You think this is cool, don't you? Think it's really cool. What do you need? What do you want? Mr. Smith, hey.
I was looking for a student.
Which one?
Not in here.
They're
We're not
similar.
important enough?
Yeah, he just does not, he strictly does not pay enough attention to
No,
me.
they're so funny. No, like, can I tell a story?
Hold on, not yet. Sorry. Hold it till later. Okay. Ask yourself, for the range, where do I have y values? Where do I have y values? Okay, and we'll talk all about this, but this is a big thing. This is going to be on the ACT. It's just all the sorts of stuff. Okay, a relation. Talk about some vocabulary. Is a set of ordered pairs. That is in the form of x, y coordinates. Okay, these are points. Okay. Domain is set of first elements, range is second set. I mean, like, what the crap? Like, why? Domain, these are your x values. Range, these are your y values. Okay? I would put a big fat star next to these. Okay, what is the domain? All right? We'll talk about that. Okay? Okay, let's take a look at this graph. Now, I'm not saying that this is a function, but it wants us to know where, okay, it says complete the inequality below to describe the domain of the graph shown, the domain. So if it wants me to show the domain, I'm asking the question, where do I have x values? Where do I start? So domain I'll do in red. Where do I start? If I go from left to right, so left to right, where do I start at on this graph? What value do I start at where I have x values? What's that number right there? Yeah, it's negative. Kentucky! Killing it right now. Okay, so negative 4. So I have x values, and that's the thing. I start at negative 4. Here's my graph. I notice that I have x values that start at negative 4.
Wait, how do you know this?
Well,
Where are you looking?
I'm looking along the x-axis.
Yeah.
And I go from left to right.
Uh-huh.
And I go, okay, where do I start at?
And so you just decide to start with
Well, where else would I start? Do I have the other? So here's the question: Do I have an x value at negative 5?
I don't, where do you put your X?
Are you looking at this graph?
Yeah.
Okay. See how I have all these different points that create this graph?
Oh, you mean.
Where do the points start?
I see.
Yeah, totally fair. Totally fair question. Okay, where do I have x values? Okay, where do I start? I start at negative 4. And then where do I stop at?
4.
Stop at positive 4. Now, I include the value at 4 because we have a closed graph there, but I have an open graph here. So I would say this, that I would say that my domain starts at negative 4, okay, and then it goes to positive 4. That's where I have x values. In between these two numbers is where I have points on the graph. Okay, I would also say, if I wanted to use interval notation, that I would go from negative 4, comma, to positive 4 and include 4, okay? Now, let's talk about our range, okay? Now the range, again, is our y values. And I'm going to go from the bottom to the top, okay? And so you have to ask yourself, and where do I start? Where do I have y values? And down here, they start at negative 2. And then I have y values that go all the way up until I get to positive 5. Okay? Now notice that we have a hole here, so I don't include the 5. Okay? Y is strictly less than 5. Okay? We have values that are smaller than 5. Okay? But we do include the negative 2. All right? So I would say this, that negative 2 is less than or equal to y, which is less than 5. If I wanted to put this into interval notation, then I would include the negative 2 with a bracket, comma, 5, and put a parenthesis. And what this says is that my y values are in between negative 2 and 5. And that's your range. Okay? All right, real quick over here. Again, a relation is just a set of ordered pairs. We can represent those using equations, words, graphs, and tables. Domain is where you have x values. Range is where you have y values. And then we have a special kind of relation called a function. Okay? This graph here is actually not a function. I can just tell that by looking at it. Not a function. Okay? This graph over here to the right is a function. So is a function. Okay? All right, let's take a look down over here. Now remember, it says over here, a function is a relation in which every domain element is paired with exactly one range element. Yuck. I have a hard time understanding that. I get it, but that's because I've been doing this for 15 years. But let's put this into terms we understand. A function is where for every x value, there is only one y value. Only one y value. Okay? So here's what I would do. Okay? This shows us something that's not a function. Okay? And this is called a function map. All right? Where basically these are your x values and this is your y value. Okay? So if I were to take this, doesn't really make any sense to you. You probably haven't seen this in a long time. But if I write these as ordered pairs, like negative 6, comma 1, because negative 6 corresponds with 1, and then if I said negative 3 corresponds with negative 2, I write that point down. And then if I say negative 3 also corresponds with 4, you guys seeing a problem with that? Maybe. And then 1 corresponds with 3. Okay, now let's think about our definition here. it says that for every x value, there is only one y value. And there's a problem with that. Because I got -3 here. Okay? -3, if I put that into my function, it gives me -2. And at the same time, if I plug in -3, I also get 4.
What does that look like on like a graph or something?
Well, it's just, well, you can just plot them as a point. Okay, -6, 1. You got a point here. -3, -2 is a point down here. -3, 4 is a point here. Those are connected by a vertical line. We'll talk about that, but that's a good question. Remember that? And so this begs the question. Let's think about a computer. Okay? Think about it. If you're in a Word document, you hit the K button, what happens? K pops up on the screen. Well, yeah. But that's still, I'm hitting a button, hitting another button, okay? And I'm getting a result, okay? But here's the deal. If you hit the K button in a Word document and you only hit the K button, does the computer open up Spotify and start playing music? Does it also start doing all these other functions, like open up your email and all that crap? If it's not functioning properly, but that's the thing. That's what you have to think about.
So that's a broken computer.
This is a broken computer, because if you hit -3, you're getting 2 different values. That means you don't have a function. Okay? If it is functioning properly, you hit the -3 and you get 1 y value out of that.
Well, if you hold it down, you get multiple.
Well, that's because you're holding it down.
You still get K.
You're still just getting, yeah, you're still just getting K's. You're just holding down K. Question?
It's mine, I'm just a little confused with mine because I'm not understanding exactly. I'm not understanding exactly what the function is. Like, how would we get the?
So let's look at what a function is. Okay? So this was not a function, because when I had if I had an x value, I'm getting 2 different y values, where I should only be getting 1. Okay? So if I were to do this function over here, again, here's my domain, my x values, and my range, my y value. So what I would say here is I have a point, -1 to -1 gives me -3. Okay? If I plug in 0 into that function, I get -1. If I plug 1 into that function, I get a +1. If I plug 2 into that function, I get a +1. Here's the deal.
You can have the same like y value.
You can have the same y value, but you can't have the same x value. Okay? Back to the computer. What happens if you hit the home button on your phone? It like turns on and it shows you all the different apps, right? That's what a function is. If I hit that single home button, that one thing happens on the phone. The phone doesn't automatically start calling all of your friends at the same time, open up Spotify and starts playing Michael Jackson. Okay? Your phone, when you hit a button, only one thing happens. Okay?
Maybe you could like modify it to.
Well, but we are trying to understand what a function is. I'm trying to put it in the terms that you understand, because you do understand this. So here's the thing. These are all different buttons that you're pressing. And I'm getting, and they're all different, right? And I'm getting unique different 1 y value. Here's the difference over here. If I hit -3, it's giving me -2. At the same time, if I hit -3, it also gives me +4. That's not a function. For every 1 x value, I should only get 1 y value. This is saying that if I hit -3, I'm going to get -2, and I'm also going to get +4.
So within the set, it just has like no one x value can have more than 1 y.
Correct.
So okay, yeah. So that's why I got.
X is like pushing the button. The result, the y value is what happens on the screen. And only one thing should happen. That's what a function is.
Gosh, okay, now I'm
Okay? All right. So this leads us to what we call the vertical line test. Okay? And so the vertical line test means that if you take, and here's what I do. To tell if you have a function on a graph, then you take a line. Okay, if I take a line, a vertical line, and if I move that line across my graph, if it hits at more than one location, then it's not a function. This is probably what you guys remember. This is like the easy one. And all you do is you just take your pencil and move it across the graph. And it should only pass through the graph once. Okay? If it passes through more than one point, you don't have a function. Okay? Because, so again, remember how I said that this was not a function and how this is a function? If I take that vertical line and I go all the way across, it's only hitting that graph at one point, at any point along that graph. That's where you have a function. Now, one-to-one means that you pass both the vertical line and the horizontal line test. Okay, so you could do the same thing and have a horizontal line and move that as well. And if you move that, so this one passes the horizontal line test, okay, but this graph does not.
What does that mean?
It's the same thing for the.
Same thing, but going the other way. So talking about
Oh,
the,
it's just if you want to do it differently.
like saying, like reversing it, switching your x and y values, and saying the same thing. Like your phone is one-to-one. It is a one-to-one function. So actually, no, it's not.
So it doesn't
Never
matter
mind.
which one you use?
Vertical line test works with a function, okay? But if you're asked to whether a function is one-to-one, you also have to do the horizontal line
Not
test.
function is one-to-one. The one that doesn't function is a one-to-one, or is it the function that is one?
Like here, let me draw a graph. So if I have the equation y equals x cubed, this function is one-to-one. This function looks like this, okay? If I were to take my horizontal line, or my vertical line, it passes the vertical line test, right?
Yeah.
Okay? If I were to take the horizontal line,
Also, it has to, so neither of those are one-to-one.
on the first one, neither of those are one-to-one.
Okay.
Yeah. But this function itself,
Is one-to-one.
come on. Okay, does that make sense?
Yeah.
Okay. All right, let's take a look. Okay, so you have this thing. Some people think of like as a function as like a machine where you put something in and you get an output and you always get something different every time. Okay? And that's kind of what I think of. I just think of a computer, all right? So, okay, to make sense of this, all right, you have this equation, okay? I can write that in function notation, where you see this thing where it says f parentheses x parentheses, okay? And what I would do, all right, to go from my equation to function notation, these things here are the same thing. They're the same. They're just written differently. F of x, okay, is a fancy word for y. All right? So if I wanted to use function notation, I'll use the notation f of x, all right, as opposed to just saying y. You can still call this a function, but this is not in function notation. This is in function notation when you have that.
So that's what we should do with when we have like a quiz question or something.
Yeah, if it's asking you about function, yeah. So then here's what you do, okay? This part right here, the x, this is your input. All right? That's where you put in your x value. So, and that's the thing. What happens is if I were to write that I'm going to plug in. So when you say input, that means plug in. Like plug in that value. And what I would do is I would say, okay, let's just say I want to plug in -2. I'm going to plug in -2 for x. I want to see what I get for y. So what I would do is I would write f of negative 2 means that I'm going to plug in negative 2 in for x and evaluate it. Like I'm pressing the negative 2 button. What happens as a result on the computer screen? Okay? And so here's the thing. You see this, negative 2, you plug in negative 2, what do you get as a result? You get 3. Okay? So when you say that you have a point on the graph, negative 2 comma 3, in function notation you would say this, that f of negative 2 is equal to 3. This and this are the same thing. Okay? It's just writing it differently. Who are you texting? Okay? And that's the thing, is that, you know, when I write this, this is like me writing a point. This is a point on a graph. Okay? This is a point on a graph. And so in this column, in this table over here, this is your x column, all right? This is your y column. But since we're calling it a function, you can call that column y f of x. F of x and y, they mean the same thing, okay, if you have a function. All right? Okay, let's take a look at this question here real quick. It says, think about the function f of x is equal to 10 minus x cubed. Well, you know, if you don't like writing it in function notation, then do this. Write y equals 10 minus x cubed. Okay? Same thing. And then it says this. What is the input? Well, what is another word for input?
X.
It's an x value. Okay? So what is your input? This is your x value. All right, boom, that's it. Okay, what is the output or dependent variable? What does it mean when you say output? That's your y value, good. All right, well, according to this, okay, what is my y value? F of x. That is your output, that is your y value. If you are given something of this form, and it's asking you what's your output, this is your output, f of x. How come I'm not saying it's y?
Why? I don't know.
Because that's function notation.
This is in function notation. They did not say y equals 10 minus x cubed. To help me understand what that means, I'm going to write y equals 10 minus x cubed. But you have to make the connection that y and f of x mean the same thing, okay? Y is your output or your dependent variable.
But would it matter which
I'm all right.
one you would answer for the second one?
Uh-huh.
Because they're the same thing. So
Well, but it depends how you, I use y because standard we use x and y on a graph, right? You don't always have to call it y. We just know that the vertical, like, you know, when you look at a graph, this is your x value, this is your y value. We could call those whatever we want. It just depends.
Yeah.
Like if you had like a height versus time graph,
Yeah, you can use any.
this is t and this is h. All of a sudden everything's changed. The only thing that's changed is just what you call them. So it depends how you call them. And so and that's just the thing, is you have to understand what these words mean. You have to know what output means. Output in your head is just going, oh, that's a y value.
So then how do you really answer these questions correctly? Or incorrectly?
It's all about understanding the notation.
So f
Oh.
of x is
And it's just because you were given this.
Right,
If
yeah,
you were given,
based on that.
yeah, it's all based on this. If you were given, let's say you were given this. Let's think about the function y equals 10 minus x cubed.
Then it would be y instead.
Then it would be y, exactly. Yeah, it all depends on how it's written and how it's defined. Good question. Okay, what does the notation f of 2 mean?
multiply by 2 output of
Does not mean multiply.
I was reading that.
Oh,
Why do I always feel like it means
You're just used to that.
I would like, even whenever I first started learning this in middle school.
Does not mean multiply. Okay. All right. So what does the notation f of 2 mean?
It's probably B, like the second one.
This is telling me, yeah, it is B. Okay. It is saying, what is the output? What is the y value when x is equal to 2? Okay. When you have this, when you have f of 2, that means that you have plugged in 2 into the function. Okay? And you're going, well, what's the y value? And well, you know what? What is that y value? So you've got, f of x is equal to 10 minus, is it x cubed? Yeah. So when it's asking me evaluate f of 2, it says, okay, plug 2 into this function. And what's the y value? I'm going to do 10 minus the quantity 2 cubed. Okay? And so you evaluate that, and you go, okay, f of 2 is equal to 10. What is 2 cubed? 2 times 2 times 2 is ocho, which is another word for 8. Who you texting? This is business, bro. My business. Okay? All right, so then it says, okay, well, what's 10 minus 8? What is that? You get 2. Okay? This is your y value. And if you write this whole statement, if you write f of 2 is equal to 2, okay, remember what that is. Okay, this is your x value, this is your y value. You just they're both 2. Kind of a bad example.
Well, it can be though, right?
Yeah. Oh yeah.
So when it's like,
Okay. This is your answer. You're looking for the answer of 2 is your y value. That's what we're trying to get.
okay, so but, okay, yeah, my question is, would the x or like f of x will always be 2 though?
No.
So it
No.
could be any other number. And it
Okay,
would
let's
still be the same number whenever.
let's do this. What's f of 1? That means I'm going to plug in 1 into my function. Look. Diamond, look up here. Okay. You know, my function was f of x is 10 minus x cubed. All right. If I wanted to plug in 1 into that function, I plug that in and I'm trying to see what y value do I get. So then I say this. I say, okay, f of 1 is equal to 10 minus, okay, 1 cubed. 1 times 1 times 1 is just 1. So f of 1 is equal to what? What's 10 minus 1?
10 minus 1 is 10.
9.
10. Oh, I'm thinking
Okay.
9.
So here's the thing. This is your x value. This is your y value. What this represents, this is a point on the graph. But this is just a different way of writing it. This means the exact same thing as me saying the point 1, 9.
Oh, okay.
That's all I'm doing. You're plugging in 1 and you're finding the y value. It's confusing. It's just written differently.
Okay, so we would use a bigger number instead of 1 like that.
Let's use 3. F of 3. That's 10 minus 3 cubed. So f of 3 is 10 minus 27. 10 minus 27, that gives us what, negative 17? So f of 3 is equal to that. This is the, when x is 3, y is negative 17.
So it'd be x negative 10.
So it'd be 3, comma, negative 17 as your point. That's it. It's hard to get used to. You know how long it took me to figure this out? It was like 5 years. I went through all of calculus, all of calc 2, all of calc 3 without knowing what the hell this meant. It's a point on a graph.
Well, because I know even for me, like, another problem is, like, the cube. Sometimes, like, how am I supposed to solve it whenever
Well, if you have 3 cubed, well, 3 squared means you have 3 times 3. If you have 3 cubed, that means you have 3 times 3 times 3. If you had 3 to the 4th power, then that's 3 times 3 times 3 times 3. Okay? All right. Gotta move on. Gotta move on. Gotta move on. Ooh! Okay. Tickets to a play cost $15 each. Write a function for the cost of X tickets. So input variable, X. And that represents the number of tickets. Okay? Output variable. Do you want to use Y or do you want to use C for cost? Let's use C. So C is cost. Okay, the relationship. Well, and actually, I'm not just going to use C. I'm going to call this function C of X. Here's what I'm saying. The cost, depending on however many tickets you sell. All right? Just like f of x, instead we're going to call it c of x. Doesn't matter. The relationship, the ordered pair, is x, comma, c of x. C of x is your y value in this case. All right? Now, the equation I would write is that c of x is equal to $15 times each ticket you sell. Here's the deal. You already knew how to do this, most likely. Maybe, maybe not. Who knows? I could write it like this, y equals 15x. What's the difference between this and this? There is no difference. The only difference is how it's written. Okay, and I'm going to write that. This and this are the same thing.
But we just have to solve for what y is.
No.
I mean,
It is showing a relationship between the cost, like the cost of tickets, all right, the number,
The total, right? Not
the total,
just
yeah, yeah. So, well, yeah.
total, like, is that, yeah, that,
So tickets to write a function for the cost of X tickets, okay? So if I wanted to write, okay, if I buy 5 tickets to the play, it's going to cost me this much. You guys know how to do that math.
yeah.
You understand that concept. I'm going to take 15 times the number of tickets I sell. The only difference is how you're writing it. All we're trying to do is model an equation, model a situation, and to say, hey, if you sell 10 tickets, how much is that going to cost?
Are we gonna need to learn how to graph this?
Yeah, it's just like how you would graph anything.
What's 15 times x?
Yeah, you just write, so that's the thing. You would just do y equals 15x. You put that into the calculator. You could put c of x is equal to 15x as well. You'll get the same thing. They are the same thing. The only difference is that this is defined specifically as a function, a cost function in terms of x. X is your variable. Cost is your y value. Same thing.
Why is it science?
Okay, let's think about this. A website charges $3 for each movie you download. They also charge a one-time sign-up fee of $14.99. Okay? So we got 2 things that are changing here. The things that change is the number of movies you download and how much it's going to cost you. Right? Those are your 2 variables. So I'm going to say this. I'm going to say x, let me zoom in. Okay, your input variable, also called your x variable, you can call it whatever you want. You don't have to call it x, but we'll call it x. X is equal to the number of movies you download. Movies downloaded. Okay? The next thing you'd say is, what is the output variable? We'll call that c. We'll call it c of x. Okay? And what does that mean?
I thought it was the fee.
Fee is a fixed cost.
Well, yeah, no, but like I know it's that number. I don't know what this is.
Well, we'll talk about it. Okay? X is the number of movies that's downloaded. C of X is the cost of watching the movies. Cost of watching the movies. Or downloading movies.
But then that would mean Y is 3. Oh wait, no, that's
This 3, this is the rate at which you pay for movies.
that's yeah.
This is the rate.
Yeah, because Y is the equals.
Uh-huh. This is a one-time fee. Okay? You add that to the cost. Okay? This is a one-time fee. One-time sign-up fee. Okay? So then think about it. Think about the relationship. Your cost depends on the $14.99 that you spend to sign up for the service, plus $3 for every movie that you download. C of X or whatever, and get rid of the M. We'll call this X.
3x plus 14.
3X plus $14.99. Absolutely. Okay.
Oh, so that doesn't even go inside of.
I'm not asking you any questions about the I'm not asking any other questions. I'm just saying write the equation, write the function. Okay? And so you would say C of X is equal to 3X plus $14.99. And what this means, and your ability to read this and go, what does every single thing in this equation mean and what does it represent? What does the $14.99 represent? That's the one-time fee. Okay? I'm going to add that to the cost that is associated with however many movies I download. So let's say it's Friday night and it's time to party. And you're like, all right, I'm going to download 2 movies to watch on Friday night, but crap, I got to pay the $14.99 just to even have the ability to download movies. All right? So I would say, okay, I got $14.99 and then plus $3 for each of those, so $14.99 plus 6, and then you get a cost. Then you get a bill. And then you got to put your credit card information in and you got to hit whatever, you know?
I think you gotta do the credit card before you do all that.
Well, before you can download the movie,
Yeah.
you got to have the credit card. Yeah, they're not going to go, oh yeah, just download the movie and we'll send you a bill. Actually, they do that if you have cable, and you do it on the cable thing.
Right, but they like try to scan.
You give them the wrong address.
Something like that. I don't know.
Yeah, but then where
Okay.
does the cable go?
catch up.
Okay, now the other thing is, it says, what is the domain of this function? Now, this is where it gets a little tricky in understanding what you need to do here, okay? Can I buy like 1.5 movies? You either buy the full movie or you don't buy the movie, right? So you can either buy 0 movies, you can buy 1 movie, you can buy 2 movies, you can buy 3 movies. There is no in between. Yeah, but that's the answer for that question. What is the domain?
Features, HD versus like
Okay.
not HD.
We'll get good at this, don't worry.